Hello Year 12, we're back with another video here. We are looking at integrating exponential functions now. We've been differentiating them and, integration, differentiation, very closely linked. And of course, integrating the exponential function, e to the x, is, not very complicated. You're supposed to remember this. The integral of e to the x dx is e to the x plus a constant. Don't forget the constant for an indefinite integral. Now, if we have something slightly more complicated in the index there, so ax plus b, well, look, perhaps you can remember that if we differentiate something like e to the ax plus b, I get a e to the ax plus b. So just to sort of tidy that up, we get 1 over a, okay, when we integrate. So that a cancels out if I differentiate it and end up back where I started from, plus the constant. So, see how that works? Here we are in very much standard form here. So the integral of e to the 3x plus 2 dx is equal to 1/3 e to the 3x plus 2 plus my constant. Okay, if I differentiate that, 3's cancel out and I just end up with e to the 3x plus 2. Wonderful. Okay, question 14, how hard is that? You could be asked to do those sorts of things. That's a good one to learn. Okay, moving along. You get these sorts of things where we say, oh look, the derivative, we know that the differential is this function, and I know the value of the function at some point, right? Therefore, find the function for me. I find these things a little contrived, but nonetheless, they're not that difficult, and we will certainly answer them if we are asked to. So, we know that function prime x equals e to the x, so therefore function x is the integral of this, which is equals e to the x. Oh, I should probably write. I should probably say this. The integral of e to the x dx equals e to the x plus a constant. Okay, so we got that. That's fine. It's my function. I've got to find out what the constant is. So, function x equals e to the x plus some constant. Now, function of 1 equals 0 equals e to the 1 plus a 0 for e, plus 0 plus a constant, e plus a constant equals 0, so my constant is equal to negative e. Therefore, my function of x is equal to e to the x, my constant is negative e to the x minus e. There we go. That's part A done. Part B, hence find a function of 0. Function of 0 equals e to the 0 minus e equals 1 minus e. There you go. That's pretty fun. Okay, moving along. Got a lot of space there. That was not nearly as complicated as the previous things we looked at, nonetheless. Now, again, very contrived I find these things. You're given the derivative, find the integral. How peculiar. Well, let's say we've got this thing here, e to the x squared. Differentiate it, use the chain rule. So, okay, let u equal x squared, therefore y equals e to the u, and y by to u equals e to the u, which is equal to e to the x squared. Also, du by dx, differentiate u now with respect to x, and I get 2x. Now, I can say that y by dx is equal to y by d times u by dx equals e to the x squared times 2x equals 2x e to the x squared. There we go, that's the differential of this. Part A. Wonderful. Unsurprisingly, B, hence. Right, what do you know? There's your answer, 2x e to the x squared. Always reassuring. You get something very similar. Well, the integral from -1 to 1, and actually, if you are a little bit sneaky here, and you go, is that possibly an even function? Indeed it is. That is an even function, so I can tell you from -1 to 1, oh sorry, it's an odd function. From -1 to 1, we are going to get an answer of 0. That is, that's what we're looking at. But nonetheless, we'll work through it. We will integrate this, and we will substitute in the -1 and 1. See what happens. The integral of 2x e to the x squared dx. What does that equal? Well, look, we've just differentiated something, and we got this thing. So, must be the primitive of this, which is e to the x squared plus a constant. Okay, normally plus constant, but this is a definite integral, so it's e to the x squared between -1 and 1, and those constants cancel each other out. The joy of erasing things. Now, if I substitute these things in, I get e to the 1 minus e to the 1. I get e minus e equals 0. E minus e equals 0 as... Oh, that looks like a 6. It's not a 6. It's a 0. As suggested, we would get a 0 there because it is an odd function. Now, it is an odd function. There we go. Those are some applications. Oh, no, they're not applications. That's how we integrate exponential functions. Jot down some questions and ask me in class.